Before the current war made ural trucks a familiar sight in news footage, most people outside Eastern Europe had never heard the name. A decade before that, the exact same name was already sitting in garages across the American Pacific Northwest on a completely different vehicle. Two separate Soviet manufacturers, both named after the same mountain range, both landed on the same engineering philosophy without ever coordinating. That's not a coincidence. That's what happens when one set of constraints shapes an entire country's industry. The average American pickup from the 1970s is either in a junkyard or behind glass in a museum. A comparable Soviet truck from the same decade is still working. So what did Soviet engineers know that Detroit didn't? Nobody in the West paid much attention to Soviet truck design in the decades after World War II. It looked crude on paper: heavy steel panels, oversized tires, engines that seemed a generation behind Western technology. The assumption was that a country still rebuilding from the deadliest war in human history couldn't out-engineer Ford or Mercedes-Benz. That assumption aged badly. The Soviet military did not design trucks for skilled mechanics. It designed trucks for 18-year-old conscripts with maybe 6 weeks of training and a toolbox that might contain a hammer, a wrench, and not much else. There would be no dealership network stretching across Siberia, no overnight parts shipment to a forward base near the Chinese border, no satellite phone to call for a tow. If a vehicle broke down 1,000 kilometers from the nearest depot, the soldier standing next to it fixed it right there with whatever was already in his hands. That single constraint wasn't one factory's decision. It was policy across the entire Warsaw Pact. A part built for a Soviet truck near Moscow needed to bolt straight onto a Polish army vehicle, an East German transport, or a Cuban military truck thousands of miles away, without custom machining or a translated parts catalog. A repair depot in Hungary could keep a convoy running using parts shipped from a warehouse in Belarus, because nobody had built competing, incompatible standards to get in the way. Western manufacturers were building competing, incompatible systems against each other. The Soviets built one system big enough to repair itself anywhere on the map. That's not an abstract claim. The GAZ-66 alone stayed in production for 35 years, from 1964 to 1999, with roughly 966,000 units built and exported well beyond Soviet borders. A design doesn't survive that long, unmodernized in any fundamental way, unless the thing keeping it alive isn't cutting-edge technology. It's the fact that every mechanic from Warsaw to Havana already knew how to fix it. The GAZ-66 shows that philosophy early. Soviet troops nicknamed it the Shishiga, and from its first year on the line, it ran a simple carbureted engine tolerant of the low grade, inconsistent fuel actually available at rural outposts, not the premium fuel a Western engine expected. That's not a typo. Soviet engineers designed the engine to run worse than it could, on purpose, because the fuel it would actually receive was worse than a lab would provide. The famous central tire inflation system, the one that let a driver drop tire pressure for mud and pump it back up for highway speed without leaving the cab, wasn't even part of the original 1964 truck. It was added in 1968, 4 years into production, once the engineers confirmed the pneumatic system could survive field conditions without a single sensor or on-board computer to fail in the cold. Western militaries eventually adopted comparable systems decades later as a premium feature. The GAZ-66 was already running the entire assembly on airlines and mechanical valves a 19-year-old with a few weeks of training could actually understand. That's the kind of detail that separates a real engineering doctrine from a marketing claim. The truck didn't launch perfect and stay that way through nostalgia. It launched simple, got one specific upgrade once the harder problem was solved, and then didn't need to change again for 3 decades. Compare that to how often a modern truck's onboard computer needs a software update just to keep the dashboard warnings from lying to the driver. Then came the Ural 375 in 1961, and this is where a lot of documentaries about Soviet trucks get sloppy, so let's be precise. The 375 ran a gasoline V8, had portal axles for extra ground clearance, and included a hand crank bolted to the front of the engine so a crew could restart a dead battery in -40 temperatures using nothing but human muscle. It's a genuinely clever truck. It's also mostly retired today, replaced by its diesel successor. That successor, the Ural 4320, entered production in 1977 and is the truck you've actually seen in recent conflict zone footage, not the 375. It kept the family's portal axles and central tire inflation, swapped in a YAMZ diesel Vive 8 for better range and reliability, carries up to 5 tons off-road, and can ford water nearly 2 meters deep with its sealing system engaged. It was also built to run in temperatures from -50 to +50 degrees Celsius, a spread that would strand most Western commercial trucks at either extreme. 50 years after that redesign, the same basic chassis is still hauling equipment through active combat zones in Eastern Europe today. A truck built to survive. Siberian winters with a barely trained crew turned out to also survive a modern war, at least the parts of it that don't involve a drone overhead, which is a distinction we're coming back to. The ZIL 131 solved a different problem entirely. Water is the enemy of electronics, and Soviet engineers knew it decades before it became a Western automotive cliché. The truck's entire ignition and electrical system came sealed and waterproofed from the factory, so it could ford rivers over 1 meter deep without a soldier climbing underneath first to wrap the distributor in plastic. It also carried dual fuel tanks and dual batteries as standard equipment, not a luxury trim, because a single point of failure on a supply route through hostile territory could strand an entire convoy behind it. It also skipped anything resembling an automatic transmission, and that was deliberate, not a budget cut. A manual gearbox has fewer parts that can fail and no hydraulic control unit to leak. A conscript could learn to rebuild it in a weekend. Nobody was rebuilding an automatic on a mountain road with a socket set and a flashlight. The decision to skip every convenience feature looked unnecessary in a peacetime factory review. It wouldn't stay unnecessary for long. The war in Afghanistan in the 1980s gave this entire philosophy its hardest test. Soviet convoys ran these trucks through mountain passes and minefields that stranded far more sophisticated Western vehicles decades later. They kept moving, not because they were sophisticated, but because every part of them assumed something would eventually go wrong, and a scared teenager would need to fix it in the dark. Vehicles that couldn't be fixed that way simply didn't make it back down the pass. If you're finding this useful, hit subscribe. This channel covers the machines and infrastructure that outlasted the era that built them every week. By the time we get to kamaz, the philosophy stops being wartime improvisation and starts looking like a competitive advantage. Kamaz engines use wet sleeve cylinder liners, meaning the cylinder walls themselves pull out and get replaced individually instead of requiring the whole engine block to be machined at a real facility. A field crew with hand tools could pull a worn sleeve, drop in a replacement, and have the truck running again without ever seeing the inside of a proper shop. Here's the number that should actually surprise you. Kamaz took that same rebuildable, overbuilt design and entered it in the Dakar Rally, one of the most punishing endurance races on the planet. As of 2022, kamaz has won the truck category 19 times, more than any other manufacturer in the race's history. 19. A truck engineered around the assumption that any conscript with a wrench could fix it also turned out to be the winningest truck in one of the hardest races that exists. That's not a museum piece achievement either. The factory in Naberezhnye Chelny is still running full production today, decades after the country that founded it dissolved. Kamaz trucks currently move freight across Central Asia and African mining operations, and the same wet sleeve engine design a conscript could rebuild. Roadside in 1976 is still the reason a truck can go back to work in places where a specialized dealership will never exist. The UAZ 452, nicknamed the Loaf for its rounded shape, pushed the philosophy furthest. Its leaf spring suspension and drivetrain components were shared across nearly the entire Soviet vehicle fleet, civilian and military both, so a mechanic on a collective farm hundreds of kilometers from any factory could keep a broken loaf running, using parts scavenged from an unrelated vehicle in the same yard. It is still in production today, largely unchanged since 1965. And now the part that actually matters if you're trying to figure out whether durable and outlasts the West are the same claim. They're not. In the current war in Ukraine, UAZ 452 vans have been taking heavy losses, not from wear, not from bad fuel, not from a decade without maintenance, but from drones. The van's thin steel panels don't stop a drone strike, and its two exposed fuel tanks, mounted low on either flank, turn a near miss into a fire. That alone would be a rough day for any vehicle. It got worse. Crews started welding improvised cage armor onto the vans to detonate incoming drones before they hit the hull, and in some documented cases added reactive armor blocks originally designed for tanks, including on the windshield. Reactive armor works by exploding outward to disrupt an incoming warhead, which is exactly what you want on a heavily armored hull. On a thin paneled van with a crew sitting right behind that windshield, the same explosion meant for a drone became a second threat to the people inside. A fix borrowed from a completely different class of vehicle made the problem worse, not better. That's the honest version of this story, and it's worth sitting with. These trucks are not indestructible. They were never trying to be. They were built to solve a specific problem, the collapse of a supply chain, and they solve that problem better than almost anything the West ever built. Ask them to solve a different problem, drone warfare in the 2020s, and the same thin panels that made them cheap and easy to repair for 70 years become the reason they burn. Western trucks from the same era still win on speed, comfort, and precision, and it is not close. A Ural 4320 tops out well below highway cruising speed. Fuel economy was never a design priority. Sitting in a GAZ 66 cab for 12 hours on a bad road is not something anyone would choose given an alternative. But precision carries a cost that only shows up the moment everything else goes wrong, when there is no dealership, no 48-hour parts delivery, no diagnostic laptop. That is the specific bet these trucks made, and outside of drone-saturated battlefields, it keeps paying off decades later. Walk through rural Africa or Central Asia today, and you will find these trucks actually hauling cargo across roads that would strand something newer, not restored for a car show behind a velvet rope. None of that makes them the better truck in some universal sense. It makes them a truck built to answer one very specific question extremely well, and that question was never how do you survive a drone. It was how do you survive everyone who was supposed to help you not showing up. Which brings us to the other ural. If you watch the motorcycle video on this channel, you already know the Ural sidecar motorcycle outlived the country that built it. Here is the detail that video did not have room for. Ural trucks and Ural motorcycles are not the same company. Ural AZ, the truck maker, is based in my ass. IMZ, the motorcycle maker, is based in Urbit, hundreds of kilometers away. Neither one licensed technology from the other, and neither one is aware of copying the other's homework. They share a name because they are both named after the same mountain range, and they independently arrived at the identical conclusion. Build for the mechanic with nothing, not the mechanic with everything. Two separate design teams, decades apart, solving completely different vehicles, landing on the same doctrine without ever comparing notes. Go watch how that philosophy played out on 2 wheels instead of 6. It is a different machine solving the exact same problem.